Let's finish the 5.1 notes. So we are going to start talking about the different parameters for the probability distribution. So probability distribution can give us insight into the nature or shape of the distribution. The following formulas can be used to find mean, variance, and standard deviation from a probability distribution. So we have those formulas. So we are going to end up using these quite a bit. So look at what this is, the summation of x times p of x. That is our mean. The variance is x minus the mean squared times each p of x, and then you're going to take the summation of that. And then this is the summation of, we find x squared times p of x minus the mean squared. And then standard deviation, you take the square root of your variance. Evaluate x squared times p of x by first squaring each value of x and then multiplying each square by the corresponding probability p of x, then adding those products together. Round your answers by carrying one more decimal place than the number of decimals used in our random variable, unless it asks for more precise calculations. All right, so this is the same table that we used yesterday. Use the previous example of choosing 12 jurors in the following probability distribution to find the mean, variance, and standard deviation. So see how this was our table to begin with, and now we have x times p of x, and then we're going to do x squared times p of x. So let's see. We have x times p of x. So 0 times 0. We're going to go ahead and just do the x times p of x, and then we'll come back and do the x squared times p of x. So you do need your calculator. Put it on this side. Okay, so the first few, all the way to 3, are going to be 0. And then we're going to multiply 4 times 1, basically. And then 5 times 3 is 15. So it'll look like that. 6 times 16 is 64. Or 96, sorry. 96. Seven times the 0.53, 0.371. 1.064. It's a little fuzzy. I don't know what's going on with it right now. That looks better. Okay, so then our x times p of x, which is called our mean, is going to be the summation of those values. So go ahead and add them up. Mean is our mu. Okay, check each other at your table. See if y'all got the same answer. Or you added those together. Make sure you didn't miss any of those values. And then you're going to do x squared times p of x. And then find the summation of that. I'm going to pause it and let y'all go ahead and do those calculations. So the mean comes out to 9.598. And so then the next part, because we want to find the variance, in order to find the variance, we're going to use this formula. The x squared times p of x minus mu squared. We are going to have to find x squared times p of x. So you'll square your x and then multiply times the p of x on each one. I'll just go through each one. See if you got those numbers. That's not right, is it? Or is it right? 9.936? Okay. Yeah. Okay, and then where we add on, you do the summation, 94.054. So in order to find our variance, we are going to do the summation and then of this. So this is our 94.054 minus mu squared. So we need to do the mean squared. So the variance equals, we are going to round it to 1 point. It says one more decimal place that was necessary. So we need to go to 4 places. Y'all agree? Okay, and then our standard deviation is found by taking the square root of the variance. So what we can do is we can do square root and then go up here and click on that number to bring it down and hit enter. Which actually, in this case, it says, it's not saying one more decimal place than the p of x, one more decimal place than the number used for our random variable. So look at our random variables. These are the random variables. So we're actually going to just do it to the 10th place. So this will end up equaling 9.6. Let's go ahead and put our symbol there. Mu equals 9.6. The variance equals 1.9. And then standard deviation is 1.4. So in the context of this problem, the mean number of jurors that are selected will be 9.6 that are Mexican American. And then we have the variance of 1.9, standard deviation 1.4. Expected value of the discrete random variable. I already wrote the definition down. So you can go ahead and copy that down. The expected value of a discrete random variable is the value that is expected when an experiment is repeated an infinite number of times. So it's given us our formula. And this is for discrete random. It's not for continuous, it's for discrete. Do you see this formula? This formula is the same as our mean formula over here. See how it's the same exact formula? So our expected value comes from the mean. So it's sometimes written as E, and sometimes it's written with a bracket of X equals mu, or the mean. So if we can find the mean, then we can find the expected value. Theoretical mean outcome for infinitely many trials. Expected value is the average value that we would expect to get if the trials were continuing indefinitely. Plays an important role in decision theory. The mean of the discrete random variable is the same as its expected value, which is what we said right here. So let's look at when selecting 12 jurors from population, the mean of the number of Mexican Americans is 9.6. So the expected value is 9.6. So we already found the mean. So now we also know that the expected value. So the expected value, E of X, equals 9.6. We had looked at another example yesterday, and that was dealing with births. So the following table describes the probability distribution for the number of girls in 2 births. Find the mean, variance, and standard deviation, and expected value for the probability distribution. This is discrete. These are our random variables. These are the probabilities of having 0 girls, 1 girl, and 2 girls with 2 births. So let's find X times P of X. So we multiply 0 times 0.25. It's going to be 0. X times P of X would be 1 times half, which would be half. And then 2 times a quarter, which would be half. So let's find the summation of X times P of X. That's adding those together. Add half and half, make 1. Let's do X squared times P of X now. Well, 0 squared times, well, it's 0 times anything, so that's 0. 1 squared times half, still just 1 times half. 2 squared times a quarter. 2 squared is 4. 4 times a quarter makes 1. So let's do the summation of X squared times P of X. So that would be 1.5. So to find your mean, you would just do X times P of X, and the summation of that, we already found it, equals 1. Our variance is found by doing what we found here, the x squared times p of x. So that's 1.5 minus mu, which is our mean, squared. 1 squared is just 1. So 1.5 minus 1 equals 1/2. And then standard deviation, you find that by taking the square root of your variance. And we are rounding it to 1 decimal place, so 0.7. And then your expected value is the same thing as your mean, which we just found, which was 1, because it is discrete. So something that's going to help you a lot is making these tables, doing the x times p of x in a table, and then x squared times p of x in a table. And then you can easily plug in the formula. Let's look at the next example. You can use expected value to compare the average gain and loss of 2 different bets. If you bet $1 in Kentucky's Pick 4 lottery game, you can either lose $1 or gain $4,999. The winning prize is $5,000, but your $1 bet is not returned. So the net gain is $4,999. The game is played by selecting a 4-digit number between zeros to 9,999. If you bet $1 on 1, 2, 3, 4, what is your expected value of gain or loss? So expected value, we are going to find the mean. Okay, so let's look at our lose, our random variable. Okay, we are going to do, you could either lose $1, so our random variable is going to be $1. Our gain is going to be our net, 4,999. So let's think about our probability of losing. So we have between 0, basically it's 10,000 events, right? 10,000 numbers. So there's a probability that you will lose all but one. 9,999 over 10,000. Probability that you win is 1 out of 10,000 of those numbers. So we'll do x times p of x. So 1 times this, it's going to be negative 9,999 over 10,000. And then 4,999 times 1 over 10,000. 4,999 over 10,000. And to find your mean, which is also your expected value, which is what we're trying to find, it's found by doing the summation of x times p of x. So it's found by adding those. So if you add these, you know it's going to be a negative number. We're just going to subtract these. We have a common denominator. So it's negative 5,000 over 10,000. We can simplify negative 5 over 10. So what is that going to equal? Negative half. Because this would end up equaling negative 1 over 2. So let's talk about it as far as expected value, gain or loss. Let's talk about it as money. So that's why I did to the nearest hundredths place. So you're expected to lose 50 cents. So if you compare, you're either going to lose $1 or gain almost $5,000. So what is the likelihood that you're going to walk away with more money than you walked in with? Not very good. If your expected value is to lose 50 cents, I'd feel better if my expected value is to be like $2,000, you know, not losing 50 cents. Let's look at the next one. The probabilities and payoff for betting $1 on the number 7 in roulette are summarized in the following table. Remember, there are 38 possible outcomes in roulette. Find the expected value of gain or loss. So we're going to do the same thing that we did up here, and they've already given us our X and our P of X. So lose $1, and the probability is 37 out of 38. So our X times P of X there would be negative 37 over 38. Or gain, so you'll win $35 if you win. But the probability of winning is 1 out of 38. I didn't have to do that. So in order to find our expected value, we would do mu, which is the summation of X times P of X. Which this one would be negative 37 over 38 plus 35 over 38. So negative 2 over 38. So our expected value is negative 0. Let's round to the nearest hundredth because it's money, 5 cents. So when you play roulette, you're expected to lose 5 cents. So remember how expected value, how we were talking about repeated over time? So if you played roulette for the whole evening, you know, and you always bet $1 and you're always betting on number 7, then you're expected to walk away with negative 5 cents. Not very good odds. Let's continue on. Making sense of results. There are 2 approaches for determining whether a value of a random variable X is unusually low or unusually high. So we have the range rule of thumb, which we've talked about this in the past, but it's been a while. In the middle, we have our mean. And then it goes all the way up to mean plus 2 standard deviations. Or it goes down, mean minus 2 standard deviations. Anything in this area is considered not significant. It's usual. It's just our usual values. But if we're above this or below this, if it's above that mu plus 2 theta, that would be considered unusually high. And then below our other value, this would be considered unusually low. So we are going to look back at that example about the jurors, and we want to know what would be considered unusually high and low. Use the range rule of thumb to determine whether a jury consisting of 7 Mexican Americans among 12 jurors is usual or unusual. So let's look back and let's draw our little number line with mu. My number line looks a little off. This is a little better. So it was 9.6. And then our standard deviation was 1.4. Oh, it sure did. Okay. So we do 9.6 plus 1.4 and 2 times 1.4, sorry, because it's 2 theta. And then 9.6 minus 2 theta. And then you do the lower value, 6.8. So remember, anything this direction and above and this direction and below would be considered unusual. So is 12 usual or unusual? I mean, 7, sorry. Yeah, 7 is usual. Let's look at the rare event rule. Yeah, I'm looking too. If under a given assumption, such as that a coin is fair, the probability of a particular observed event, such as 992 out of 1,000 coin tosses, is extremely small, we conclude that the assumption is probably not correct. Unusually high number of successes. If the probability is less than or equal to 0.05 number of successes, and P of X is unusually high. And then we have the other one, which is talking about also P being less than or equal to 0.05. So you're looking at the difference between them. Okay, so I'm going to go ahead and turn on the assignment for y'all to do. We're done with these notes for today.